Andrewsarchus mongoliensis was a large predatory mammal that lived during the Middle Eocene, approximately 45 to 36 million years ago, primarily in what is now modern-day Mongolia. The only fossil known from this species, a skull, was discovered in 1923 by an expedition of the American Museum of Natural History, led by Roy Chapman Andrews. Although a complete skeleton has not been found, the morphology of the skull and dentition offers significant insight into the animal's ecological role and lifestyle. This section explores the probable causes and timing of the species' extinction within the broader context of geological and environmental change. Time of extinction. Fossil evidence indicates that Andrewsarchus mongoliensis is found only in sedimentary layers from the Middle Eocene. It is absent geological records from the late Eocene and Oligocene periods. This strongly suggests that it went extinct during the Eocene-Oligocene transition, approximately 36 to 34 million years ago. This transition was one of the most significant periods of climatic and ecological transformation in Earth's history, characterized by global cooling, a drop in sea levels, and widespread extinction among both terrestrial and marine species. Causes of extinction, climate cooling, and ecological stress. By the end of the Eocene, global temperatures began to fall sharply. This climatic shift led to a reduction in forested areas and a decline in plant biodiversity, especially in continental interiors. As a result, populations of herbivores began to decrease, which severely disrupted the food chain and caused ecological stress for large apex predators like Andrewsarchus. Decline in food resources. Large-bodied carnivores require a constant supply of high-calorie prey. Andrewsarchus likely depended on medium to large prey or carrion. As global temperatures dropped and herbivore numbers declined, food scarcity would have become a serious threat. The drop in available biomass made survival increasingly difficult for such large predators. Evolutionary competition. During the early Oligocene, new groups of carnivorous mammals began to emerge and diversify, especially the first representatives of the order Carnivora. These animals were generally smaller, more agile, and ecologically more adaptable than Andrewsarchus. As a result, these new predators likely outcompeted the older, less adaptable species in shared ecological niches. Evolutionary stasis and lack of plasticity. Though Andrewsarchus was well adapted to the Eocene environment, its large body size and highly specialized morphology probably limited its ability to adjust to changing conditions. This phenomenon, evolutionary stasis, meant that Andrewsarchus was vulnerable to extinction during rapid environmental transitions. Natural selection and ecological elimination. According to the principles of natural selection, organisms that cannot adapt to new environmental conditions face extinction. Since Andrewsarchus occupied a top predator niche and was highly specialized, it lacked the ecological flexibility to survive climate cooling, food shortages, and increased competition. This ultimately led to its disappearance. The extinction of Andrewsarchus mongoliensis was driven by a complex combination of factors: global climate change, disruption of ecological food chains, evolutionary competition, and limited adaptability. It most likely disappeared during the Eocene-Oligocene transition, about 34 to 36 million years ago. This case serves as a classic example of how apex predators can be among the first to vanish in the face of rapid environmental change. Feeding behavior and lifestyle of Andrewsarchus mongoliensis. Scientific knowledge about the feeding behavior and lifestyle of Andrewsarchus mongoliensis is based solely on a single known fossil, a skull, and on morphological, ecological, and evolutionary analyses derived from it. The following presents scientifically grounded hypotheses about this species' likely feeding strategies, ecological role, and behavioral characteristics. Feeding behavior, based on dental morphology. The shape and structure of Andrewsarchus's teeth indicate that it was a carnivorous animal. Its teeth consisted of the following types: incisors, front teeth, relatively small but clearly defined, likely used for tearing flesh. Canines, very large and sharp, played a major role in seizing, biting, and tearing prey, its primary weapons. Molars, broad and strong, adapted for crushing bones, suggesting possible scavenging behavior as well. The skull structure and jaw muscle attachment points suggest Andrewsarchus had extremely strong jaw muscles. This would have enabled it to generate a powerful bite force, making it likely that its diet included not only flesh but also bones and marrow, allowing it to consume whole carcasses efficiently. Predator or scavenger. Two scientific hypotheses. Active predator hypothesis. Most paleontologists believe Andrewsarchus was an active predator. It likely relied on its large size and powerful jaws to hunt prey smaller than itself. It may have been capable of long-distance pursuit and exhibited aggressive hunting strategies. Likely prey might have included early ungulates, hoofed mammals, primates, reptiles, large birds, or their eggs. Support for this view comes from its large skull, dental features, and the inferred strength of its bite. Scavenger, bone crusher hypothesis. Another theory suggests that Andrewsarchus was primarily a scavenger that fed on the remains of dead animals. Support for this hypothesis includes the molars are smooth and flat, ideal for bone crushing. During the Eocene, many large predators existed, making scavenging a viable but competitive niche. Its ability to crush bones and extract marrow could have reduced competition by utilizing a specialized feeding strategy. Possibility of omnivory. Some scientists propose that Andrewsarchus may have been omnivorous, capable of hunting, scavenging, and possibly consuming plant material. While direct evidence is limited, this dietary flexibility might have helped it survive in changing environments. Lifestyle. Habitat. Andrewsarchus likely lived in open plains or semi-desert environments. Geological evidence from the Gobi Desert indicates that such landscapes existed during the Eocene, characterized by arid or semi-arid conditions with occasional rainfall, a variety of small ungulates and other prey animals, open spaces ideal for pursuit and hunting. Activity cycle. It was probably diurnal, active during the day, though it might also have hunted at night or early morning. It may have used stalking behavior or traveled long distances in search of food. Social behavior. Andrewsarchus is believed to have been solitary. Like many modern large carnivores, it likely defended a territory and had confrontations with other individuals. This suggests a mostly independent and solitary lifestyle. Ecological role. As a high-level predator, Andrewsarchus likely played several key ecological roles: regulating populations of prey species, scavenging carcasses, helping reduce disease spread, contributing to nutrient cycling through bone consumption. Andrewsarchus mongoliensis was a powerful predator with strong jaws, adapted to hunting and possibly scavenging. Although no full skeleton has been found, available fossil evidence suggests it was a dominant force in its ecosystem, yes, likely leading a solitary and territorial life in open landscapes. Andrewsarchus mongoliensis, evolutionary history and ecological significance. Andrewsarchus mongoliensis was a carnivorous mammal that lived during the Eocene epoch, approximately 45 to 36 million years ago. It has attracted significant scientific attention due to its unusual cranial structure, enormous size, and possible ecological role. Studying this species is crucial not only for understanding the morphological features of ancient predatory mammals, but also for reconstructing the paleo environment in which it lived. Although some popular sources refer to Andrewsarchus as the largest wolf, it was not a wolf and has no direct evolutionary connection to canids. Historical discovery. The only known remains of Andrewsarchus were discovered in 1923 during an expedition organized by the American Museum of Natural History and led by Roy Chapman Andrews in the Gobi Desert of Mongolia. The fossil consists of a single incomplete skull, yet it provides a rare glimpse into one of the largest terrestrial carnivorous mammals known to paleontology. The skull measures about 83 centimeters in length and is distinguished by its powerful jaw musculature, massive jaws, and well-developed teeth. Although a complete skeleton has never been found, scientists have made estimates about its body structure and ecological role based on its skull morphology. Morphological characteristics. Skull. The skull of Andrewsarchus is extraordinarily large and shows distinct structural adaptations. It is wide and elongated, with orbits, eye sockets positioned relatively high. The teeth reflect carnivorous habits. The front teeth, especially the canines, are large and smooth, perfect for killing prey, while the back molars are broad and strong, capable of crushing bones. Body structure, based on reconstructions. Because there is no complete skeleton, interpretations of its body structure vary. Some reconstructions depict Andrewsarchus as resembling a large boar or a wolf-like mammal. Estimated shoulder height ranges from 1.5 to 1.8 meters, with a body length of 3 to 4 meters. Its body weight is estimated at around 800 kilograms, with some individuals possibly reaching 1,000 kilograms. Paleoecology and lifestyle. Andrewsarchus lived during the Eocene epoch, a time marked by warm, humid climates, dense vegetation, and rich biodiversity. It probably inhabited open plains and arid grasslands, based on the sedimentary context of the fossil site in the Gobi Desert. The species may have been a top predator or a specialized scavenger. Its powerful skull and teeth suggest it was well equipped to hunt prey, crack bones, and feed on carcasses. Some scientists even propose that it may have been omnivorous, consuming whatever food was available, from meat to plants. Evolutionary relationships. The evolutionary placement of Andrewsarchus remains a topic of debate among paleontologists. Some researchers classify it within the extinct family Mesonychidae, an ancient group of predatory mammals thought to be closely related to even-toed ungulates, Artiodactyla. Others believe it is more closely related to Artiodactyla, a group that includes whales and aquatic even-toed ungulates. These conclusions are based on shared morphological features in the skull and teeth. Scientific and cultural significance. Andrewsarchus continues to spark interest in the fields of paleontology and evolutionary biology. As one of the largest known terrestrial predators, it is a central subject in studies of mammalian evolution, ecological systems, and comparative anatomy. The species has also entered popular culture, often featured in documentaries, educational media, and digital reconstructions as a symbol of prehistoric predatory dominance. Conclusion. Andrewsarchus mongoliensis is a scientifically intriguing and still only partially understood predatory mammal that likely held a top position in the Eocene food chain. Its massive size, powerful skull, and unique dentition make it an important species for understanding the evolution of mammalian carnivores. Although the absence of a complete skeleton leaves many unanswered questions about its biology, the existing fossil evidence offers valuable insights into its ecological role and evolutionary relationships.